In this video, we will be looking at how to solve more complicated equations. The process we applied in the previous exercise set still holds here to be true. We're still going to be using the same technique. It's just going to be a little more complicated. And so if we look at our first example, we have 1/2 times the quantity 4x minus 6 equals 3 times the quantity 2x minus 9. What you want to do first is the same thing. You want to simplify the left and the right side first. So I'm going to distribute the 1/2 into the parentheses. So half of 4x is 2x. Half of 6 is -3. And then you have 3 times 2x and 3 times -9. So that gives me 6x minus 27. And so what I'm going to do is get the variables on one side of the equation. And so I'm going to move the 2x by subtracting 2x from the left side. And so I'm going to do it to the right side to keep the equation balanced. And so 2x minus 2x cancels. I'm left with -3 equals 4x minus 27. And then I would add 27 to both sides and get 24 equals 4x. If I divide both sides by 4, then I would get x equals 6. You would say 6 equals x, but in your final statement, always put the variable on the left side for it. And so there is our solution, x equals 6. If we look at the second problem, this one, fraction equal to fraction, may cause some people some anxiety at the beginning to look at, but you've done this before. You have a proportion here. It's just you got a variable expression in both numerators. Who cares? It's still the same concept. If you have a fraction equal to a fraction, the technique you use to solve is cross multiplication. And so that's what we're going to do is we're going to cross multiply. Now that only works if you have a fraction equal to a fraction. If there were a plus or minus sign out here, wouldn't work. And so if you have two fractions equal to each other, cross multiply. The 6 would be multiplied to the 4x minus 3, that entire quantity, 4x minus 3. So it's a quantity. I'm going to put it in a parentheses, and that 6 is going to be multiplied by it. It's the same here. This 2x plus 5 is a quantity. It goes inside of a parentheses. And the 8 would be multiplied by that. And so once you do that, it doesn't look too bad. It looks very similar to this problem, except for here we have integers, and here we had a fraction. So same idea, distribute the 6 to get 24x minus 18 equals, and then distribute the 8 to get 16x plus 40. Same idea, I'm going to get the variables on one side by subtracting 16x, and that's going to give me 8x minus 18 equals 40. Now what I'm going to do is solve for this variable. I would add 18 to get 8x equals 58. And then I would divide both sides by 8. Now when you do that, I'm going to show it in this step. And the reason why I'm going to show it is because 8 does not go into 58 nicely. I'm going to have to simplify that fraction for it. And so I know that 2 goes into 8 and it goes into 58. And so if I take 58 and divide by 2, I get 29. Now if I take 8 and divide by 2, I get 4. And so 29/4 is my answer. So sometimes your answer is going to be a fraction. That's okay. That's one of the reasons why it's important that you use your calculator and just plug it in and make sure you're doing the process correctly. And so these two examples dealt with solving for a variable and getting a numerical solution. If we were to scroll down further, we would see we have two examples on solving for a variable when there's a lot of variables inside the problem. And so here it's gonna be a little different for you, but it's still the same process. If I want to solve for x, that's what I need to isolate. And so the first thing I do is, can I simplify? And I can't for it. Then I go, okay, well, if I can't simplify, I need to get that term that contains the variable by itself first. So I need to remove anything that's being added or subtracted. And so I need to remove this negative 2y. And the way I'm going to do that is by adding 2y to both sides. And when you move from one side to the other, make sure you write it in standard form. So I get the 1/3 x equals, and I say standard form, their variable term comes before the constant. So it's a positive 2y, and that is a positive 9, so plus 9. And so this is good. We have 1/3 x, we just want x, but it's a fraction coefficient, and we learned that when you want to get rid of a fraction coefficient, you don't divide by it, you multiply by the reciprocal for it. So I'm going to multiply by 3/1, which, come on, if I say 3/1, you should know that's just the number 3. And so if I multiply the left side by 3, I'm going to have to multiply the right side by 3. And when you multiply the right side, it's the entire right side. The whole expression, the quantity is going to be multiplied by 3/1, which is just 3. And so you need to put and insert your own parentheses. And the whole point of multiplying a number by its reciprocal is to cancel it out, to just give you a coefficient of 1. It just gives you the variable by itself. And so I get x equals. And then I would distribute the 3 to the 2y, 6y, and the 3 to the 9 plus 27. And so if I want to solve for x, x equals 6y plus 27. And that is the solution. So the process was very similar. We are going to simplify and then start solving. Now here, it's a little bit trickier for it. You can still use the simplify and solve, distribute and go from there, but I'm not going to. I'm going to use a different technique. And if you were to go back and watch the video on how to solve equations, you would see sometimes it's helpful to multiply out by the least count multiple, or it's helpful to do something different. So what I'm going to do is I'm going to get rid of this fraction first. Why do I want it there? It's going to make it so complicated. I mean, if you don't like fractions, what are you going to do? Oh, I'm going to distribute it in. So not only do I have a 1/2, I'm going to have a 1/2 B1, I'm going to have a 1/2 B2. So now you have two fractions instead of one. It's making the problem look more complicated. So don't do it. How do you get rid of this? Well, take a look. What's going on? 1/2 times the quantity. I said the word times. And then again, this quantity, you have times h. That entire right side is multiplication. And so let's get rid of that fraction. I'm going to multiply and get rid of it by multiplying by 2. And so I'm going to multiply the right side by 2. And what that's going to do is that's only going to get rid of this fraction. It's not going to affect anything else. So I get rid of the fraction by multiplying by 2 on the right. So I'm going to have to do it on the left as well. And for it. And so I have 2a equals the quantity B1 plus B2 times h. I'm still trying to solve for B1. It's inside the parentheses, which, by the way, is helping us because that means it's protected right now. We can't just go in and grab it. We have to get rid of everything on the outside first. So even thinking of it that way allows us to see the steps. The B1's protected in the parentheses. So get rid of everything outside of it first, and then we can reach in and get it. And so keeping that in mind, I got to get rid of this h. Well, this h is being multiplied to that entire quantity. So I'm going to divide by h on the right side and divide by h on the left side. And that way, these can cancel. So really, I have 2a over h equals, well, now all that's left is b1 plus b2. And so I'm going to solve for b1. So I would subtract b2 from the right and the left side. And so I get 2a over h minus b2 equals b1. and that is your solution. So this one was more complicated and involved a whole different technique when solving. We did not, in the beginning, distribute and then start solving from there. This was the exception to the rule. It was easier to just get rid of it right away. And so that's why I need you to understand memorizing steps is not important. Understand the process that you can use to solve, and it'll make your life a little bit easier for it on those harder problems.